On some distant night, far from city lights, you might glance up and marvel at the stars above, tiny, shimmering points scattered across a canvas of darkness. But those pinpricks of light don't tell the full story. Behind the veil of visible light lies a universe of staggering extremes, stars that defy scale, size, and expectation. In the ever-changing wilds of the cosmos, even giants are not eternal. One by one, the old kings fall, and new ones rise to take their place. And today, a new star has emerged from the shadows to take the top spot as the largest known in the universe. But as always, there is more to the story. You're watching The Hidden Universe. And if you enjoy diving into the wonders of space, don't forget to subscribe for much more to come. Not so long ago, I made a video exploring WOH G64, a once red supergiant that had, at the time, claimed the title of the largest known star. It was a true giant, estimated to be around 1,540 times that of the Sun, shrouded in a torus of dust, and glowing like a dying ember in our neighboring galaxy, the Large Magellanic Cloud. If placed in the solar system, it would have engulfed the orbits of Mercury, Venus, Earth, Mars, and even Jupiter. Back then, it seemed like astronomers might have found an accurate answer to an endlessly shifting question. But stars are constantly changing, and just like UY Scuti and Stevenson 2-18 before it, new measurements and fresh data are once again reshaping the largest star list. Recent studies suggest that WOH G64 may have undergone a dramatic transformation. Following what might have been a 30-year-long outburst, it's believed to have transitioned from a red supergiant into a yellow hypergiant, a rare and short-lived phase in a massive star's life. That change doesn't just affect how we classify it, it also dramatically alters its size. Current estimates now place it at around 800 times the size of the Sun, still enormous, but nowhere near the largest. Measuring a star sounds straightforward on the surface. Point a telescope, crunch the numbers, get the size. But in reality, it's far from simple. Stars, especially red supergiants, aren't solid spheres with clean edges. They're roiling balls of gas, with outer layers that puff out and recede depending on their stage in life. Their atmospheres stretch out into space, sometimes so thin they blend with the surrounding interstellar medium. And they're often cloaked in vast clouds of dust, making their true size hard to pin down. Distances are also tricky. A small error in how far away a star is can throw off its calculated radius by hundreds, sometimes thousands, of solar radii. And even when there is reliable data, stars are dynamic. They change. They shed mass. They expand. They contract. In a way, asking for the largest star is like trying to find the largest wave in the ocean and then freeze it mid-motion. Even well-studied stars can surprise us. Take the so-called Godzilla star, a nickname for a hyperluminous object with wildly inconsistent size estimates. Depending on the model, its radius could be as small as 430 or as large as 2,365 times that of the Sun. That kind of uncertainty illustrates just how slippery these measurements can be. And that then takes us to RSGC1 Ref01. With WOH G64 now reclassified and scaled down, this red supergiant, nestled inside the RSGC1 cluster within our own Milky Way galaxy, has become the newest contender for the title of the largest known star. Estimates place RSGC1 F01 at around 1,450 to 1,530 times the radius of the Sun, though some calculations allow for a wider range, from about 1,100 all the way up to 1,860 solar radii. Meaning that if it was inside our solar system, it would be close to the orbit of Saturn. That places it right up against the theoretical limit for how big a star in our galaxy can grow, roughly 1,700 solar radii. Beyond that, it is thought that the outer layers of the star become so diffuse they're no longer gravitationally bound, blending into the interstellar medium. But unlike previous record holders in more distant galaxies, RSGC1 F01 has one advantage: it's closer, at about 22,000 light-years away. That proximity gives astronomers a slightly better chance of gathering accurate measurements. But just as RSGC1 F01 steps into the spotlight, another distant giant whispers from the shadows, HV888. Found in the Large Magellanic Cloud, HV888 has been estimated to span between 1,477 and 1,584 times that of the Sun. Perhaps even larger than RSGC1 Ref01, depending on which data you consult. But in truth, this shifting crown is part of what makes astronomy so fascinating. With every new telescope, every new method, our picture of the universe changes. Stars are not static. They live, they evolve, they die, often in spectacular fashion. And the process of cataloguing the largest star is less like writing a record in stone and more like updating a living document. New contenders will emerge. Older ones will be re-evaluated. And what we believe today may be overturned tomorrow. Thank you for watching video. Like and subscribe your channel.